Hello, my name is Matthew Ankeny. This is my modular wind tunnel that I created to be run through an Arduino. This system allows the user to control and measure the airflow through the full system, through the full wind tunnel, through a closed loop feedback system. The goal of this is for the user to set a desired airspeed, the system to measure the actual airspeed using sensors, and then automatically adjust through the Arduino and a PID control system to match that desired target. Now I can demonstrate the various features of the full wind tunnel that'll help us to understand how this thing works. All right, now flowing in just like the air, we have our contraction cone, which we have a honeycomb filter going in. We have an interchangeable slot, so we could change that out and create different filters. We have our test section over here, which I modeled a little plane in here to help us visualize what's going on the inside. Integrated this little door so we could access anything going on the inside as well as anything from underneath. We have a pediostatic probe over here with a stagnation hole in the front and a static hole on the side. Stagnant in the front to measure the dynamic pressure as well as the static pressure, the pressure of the air that's not moving. And then over here we have our electrical box. I'll get into that more so later, but this is more so our user input and user output. And then moving on to the other end of our wind tunnel, I have our array of 2x2 PC fans to help us power and meet our desired wind speed. All right, to get this thing started, we have a little power on and off switch on the side of the electrical box, which you turn on, which will run a quick diagnostic test to help calibrate our pressure and our full system going through. I lift the gate to help monitor that a little bit easier. We have two RFID scanners, or two RFID devices to help scan it. You can scan it, which gives us a little access denied ring, as well as a granted. There we go. Now we can start measuring our wind speed. Hit go, test length, and then as we're able to, scroll through our little test screen. It goes, as it starts to amp up to our speed, gets to our actual wind speed. We get to our model length where we're able to edit it, able to hit a Reynolds number, which tells you we're hitting about the transitional flow condition. This is our pulse width modulation. Screen our differential pressure to help us display, and a little error to see how far off we are from our desired speed, as well as going back to our actual wind speed. Now if we could edit it up to our max speed here, or about 11 meters a second, we could see as it will very quickly get up to speed as our fans power on. About 90, there we go. Get to our differential pressure, getting about 5% error on our wind speed, and as we can see, our wind tunnel is doing pretty good. And if there's any issue where someone comes up here and says, I want to start running it, they can hit their little system, access denied, full system turns off. All right, let's get into this electrical box. We have a 24 volt power supply coming from the wall. This helps go into our kill switch, and from this kill switch, it helps power our fans and then runs into a buck converter, bringing that 24 volt down to 5 volt to help power the rest of our Arduino. Going to our Arduino, we have our I2C controller in the corner, which helps control our LCD screen. Then we have our joystick. Right next to it, we have our RFID scanner underneath with a buzzer for our indicator on access granted or denied. And then we have our differential pressure from our pediostatic tubes to help our Arduino read the pressure and velocity of the inside of the wind tunnel. From that, the Arduino takes that signal through a pulse width, this blue wire going to the fans to help control our fans. And there's a little safety feature. I added this green wire. I have a one fan representative, so our Arduino knows how fast each fan is running. Thank you for listening to my wind tunnel.